Stars, I'm a fool for your love.
Hello and welcome to Pint Stuff. On our series of How Far Are We? In our last video we have discussed how far are we from first human brain transplant. Please check that video in the description. In today's video we are going to discuss how far are we from achieving light speed in space travel. The speed of light in a vacuum is 299,792 kilometers per second. If you could travel at the speed of light, you could go around the Earth 7.5 times in 1 second. So currently the fastest spacecraft is New Horizons, which was launched on January the 19th, 2006, from Cape Canaveral, directly into an Earth and solar escape trajectory. Holds the record with an Earth relative speed of about 16.26 kilometers per second, which is just 0.0053% compared to speed of light. Despite how far we've come in space exploration, one thing still holding us back from interstellar travel is our slow spacecraft. While we're able to propel particles to close to the speed of light in the lab, we're struggling to even accelerate spacecraft to beyond 3% of that. With our current technology, it's estimated it'll take humans around 5 months to reach Mars. But NASA scientist Philip Lubin is working on a system where lasers propel spacecraft with giant sails to the red planet in as little as 3 days. Much like a Bilmy's much-hyped solar sail, this photonic propulsion system relies on the momentum of photons, particles of light, to move forward. But instead of photons from the sun's rays, Lubin's design would be given a push by giant Earth-based lasers. It sounds pretty far-fetched, but in a video for NASA 360, Lubin explains that the technology is very much readily available, and that the system could easily be scaled up. But let's step back for a second and investigate how the system works. Right now, when we launch spacecraft, the thrust comes from burning a chemical, such as rocket fuel. Not only does this fuel source weigh down spacecraft, it's also an incredibly inefficient system when compared to electromagnetic acceleration. Photonic propulsion, on the other hand, works in theory, regardless of the scale, making it a more viable candidate. So how do photons work to propel something as big as a spacecraft? Despite not having any mass, particles of light have both energy and momentum, and when they reflect off an object, that momentum is transferred into a little push. With a large, reflective sail, it's possible to generate enough momentum to gradually accelerate a spacecraft. While Lubin and his team haven't yet tried out their system, their calculations show that photonic propulsion could get a 100 kilograms robotic craft to Mars in just 3 days. Lubin also explains that in the 10 minutes it will take to get the SLS into orbit, photonic propulsion could propel a spacecraft to an unheard of 30% the speed of light, and it would also use a similar amount of chemical energy, 50 to 100 gigawatts, to do so. But the real benefit of photonic propulsion comes over longer distances, where the spacecraft has more time to speed up, and could eventually take us outside our solar system and to neighboring stars. To be clear, The system isn't designed to send humans across interstellar distances. First of all, robots are far better equipped for that mission, and secondly, we'd be far too heavy. Instead, Lubin proposes wafer-thin spacecraft that can get close to the speed of light. Lubin and his team last year received a proof of concept grant from NASA to show that photonic propulsion could be used for space travel, so should start seeing some real-life results soon. Let's hope that the reality lives up to the hype and we can see the spacecraft traveling near to 30 percentile of speed of light. Look for a new video next week, so please subscribe and press the bell icon.